All right, this is 10.2 geometry. Number 24 through 34 is a proof. So we went through it in the ninth grade class this morning, but we didn't record it. So I'm going to record it in case anyone's absent, and that way I can try to get different things on recordings in the 10th grade class. So we're told here that we've got these triangles, and it appears that they're similar, and they're wanting us to prove they're similar. And they tell us that MN is a midsegment of this triangle. Well, I'm going to write down something. Since I know that's a midsegment, don't I know, what does that mean? Doesn't it mean that MN is half of the length of BC? So I'm just going to write that down so I'll remember it in case it comes up in the proof. So I'm just kind of trying to remember some things about midsegments. Do you also remember that for midsegments that they're parallel, so it has to be parallel to the base? And one thing that is going to help us in this proof is if I extend these lines a little bit so I can think about parallel lines and angles. That's going to come up in this proof, so I'm going to go ahead and put that there. So we're going to get started, and I'm going to draw a line just so that we know that, I'm starting the proof down underneath it. And so, of course, each statement they make, they give it a different number in this book, so that's what I'm going to do. MN is parallel to BC. Well, why is that true? Well, that's true because of the definition of what a midsegment is. A midsegment is parallel to the base, and it hits the midpoints of each side. As a matter of fact, since I just remembered that, what I'm going to do is go ahead and mark that on my triangle, that this piece is equal to this piece, and this piece, I'll put 2 marks on it, is equal to this piece. So the two sides that have the 2 marks, they're equal. Because if you remember, a midsegment is you find the midpoint of each side and then you join them. That's going to come up in the proof too. That's one of the reasons why I went ahead and just brought that to your attention since we were talking about a midsegment here. All right, step 25. They tell me that angle AMN is equal to angle B, and angle ANM is equal to angle C. So let me mark this. AMN is equal to B. I'll put 1 mark on those. And ANM, I'm going to put 2 marks on it, though they're not showing up just great, is equal to angle C. Well, why is that true? Well, because these are parallel lines, and those angles that they mention that are equal to each other, they are corresponding angles. So corresponding angles are congruent, or they are equal. So that's my reason for 25. And the only reason I knew that was because the midsegments are parallel, so I could look at parallel lines. That's why I extended those red lines so that maybe you could see it a little bit better. All right. So what they're going about doing now is showing that the angles are all equal. And the reason they're doing that is because if we want to prove that these triangles are similar, I need to show that the angles are equal, and then I need to show that the sides are proportional. Now, when I gave you notes, I told you a bunch of things about triangles that they haven't told you at this point in the book. So you may think this is overkill, but it's because they haven't introduced all those similarity theorems to you, like angle, side, side, angle, all that stuff. So that's why they're going to go through such detail here to prove things. Now, angle A on 26, they say angle A is equal to angle A, and that's the reflexive property. The reflexive property just says anything is equal to itself. What they've just done, they just showed you that all the angles in the little triangle were equal to the angles in the big triangle. The ones that match up are equal. That's part of what I need to do to show that this is similar if I don't have all those similarity theorems that I gave you in your notes. Now 27 is starting kind of going on a different path. They're getting ready to try to show you that all the sides of these 2 triangles, the little one and the big one, AMN and ABC, they're trying to show you that the sides are proportional, and this is going to take a bit of doing. So if you look at number 27, MN is equal to a half BC. How did I know that's true? Hey, that's what the definition of midsegment tells me also. So I'm going to write that down, definition of midsegment. That's going to show up a lot in our proof. All right, so now they go to step 28. Step 28 says MN over BC is equal to a half. Where did that come from? Well, if you look, they took MN and they divided it by BC. So they divided both sides by BC. It canceled out over here on the right-hand side and just left this half. And over here we ended up with MN over BC. So the reason for that would just be division. Okay? Okay, even though I hate to, I'm going to have to go over to the next page and leave the diagram, so you'll want to look back at your notes as you do this part or at the book. 29, I don't know why I wrote that in green. They say AM is equal to MB and AN is equal to NC. Why is that true? Well, that's because they told us that MN was a midsegment. And the midsegment is formed by joining the midpoints. So we know that you could just write definition of midpoint here if you wanted to. M is the midpoint of AB and N is the midpoint of AC. And so a midpoint splits things into two equal halves. So on the left side, AM is equal to MB, and on the right side, AN is equal to NC. Okay? Step 30. AM plus MB is equal to AB. Okay, they're just saying if you join those two pieces on the left side, you get the whole piece. And AN plus NC is equal to AC. If you join the two segments on the right, you get the whole length. And that was from a long time ago. That reason is the definition of betweenness. And it's, okay, so that was, kind of a weird one, but that's what we would want to use there. 31, 2AM equal AB, and 2AN equal AC. Where did that come from? Well, if you look up here, AM is equal to MB, so what they did is it's like they marked that out and they put an AM there, and so AM plus AM would be 2AM. And here they did the same thing. They marked out NC and put AN plus AN, since they're equal, and got 2AN is equal to AC. That's just substitution, isn't it?
I'm actually supposed to be supervising kids in my room, but I'm starting to slowly bring stuff down.
Okay, so 32. AM divided by AB is equal to 1/2, and AN divided by AC is equal to 1/2. How'd they get that? Well, here's how they did it. They put a 1 in front of each of these terms, and they divided the first one here. They divided both sides by AB. The AB's canceled out and left me with 2AM over AB on the left side. And then they divided both sides by 2 to move the 2 to the other side. And they did the same thing on the second equation. So that's just basically, they did two divisions. They did two steps of division. So I'm just going to put division. We're getting there. Almost. Not quite. 33. 33, they make the statement that AM over AB is equal to AN over AC is equal to MN over BC. Where did they get that? Well, let's look. AM over AB is 1/2. AN over AC is 1/2. And up on the other page, if you were to scroll back in the video, we saw that MN over BC was 1/2. So since they're all equal to 1/2, they're equal to each other. So I could call that substitution if I wanted to. Substitution. And now they make their last statement. Their last statement is that triangle AMN is similar to triangle ABC. And the reason is, it's basically the definition of what similar means. We showed that the angles, the matching angles, or the corresponding angles, if the matching angles or corresponding angles are congruent, and if the sides are proportional, and we just showed in step 33 that the sides were proportional. If we make fractions out of all the sides, they reduce down to the same value, 1/2 in this case. Then the triangles are similar. And so that's how we prove it. You could have put definition of similar there. If we had been using the theorem that I gave you in your notes, we could have stopped a long way back after step 26 and said, oh, they're congruent by angle. But in this book, they haven't introduced that yet, so that's why they go through this whole step. Plus, this is kind of a cool proof to look at.